Okay, in this video, we're going to be going over the test review. So it says use the following Venn diagram to answer questions 1 and 2. And so we have a Venn diagram of seniors at Nib High School. And it says that we're looking at Snapchat users and Instagram users. And it asks, what is the probability that a student is a Snapchat user? So what we need to do is we need to look at, first we need to figure out how many total students there are. So if we add up 91 and 39, 23, and 17, we should get a total of 170 students. So we're looking at students that use Snapchat. So we want to focus on all the students that are inside of the Snapchat circle. And so we've got 91 and 39, that makes 130. So 130 out of the 170 are Snapchat users. That's equal to 0.765 or 76.5%. And then, here, let me box off my final answer. It says, what is the probability that a student is not an Instagram user? So since we're looking at the students that are not Instagram users, we want to look at everything outside the Instagram circle. So we're not going to be looking at 39. We're not going to be looking at 23. We're just going to be focusing on the 91 and the 17. So 91 plus 17, that's equal to 108. So 108 out of the 170 total, that gives us 0.635 or 63.5%. Now, number 3 says a study has been done to determine whether or not a certain drug leads to an improvement in symptoms for patients with turophobia, which is actually the fear of string cheese, and that's actually true. So it says the results are shown in the following table. Before we go any further, we want to complete this table. So we want to look at all the totals for the columns and the rows. So if we add up all the people who had improvements, we would get 410. Without improvement or no improvement, we'd get 790. And then our totals for the rows will be 820, 380, and 1200. And now the first question is, based on this table, what is the probability that a patient shows improvement if it is known that the patient was given the drug? So if it is known, this is a given statement, okay? So we want to focus on the patients that have been given the drug. So if we look at the drug column, out of the 820 total, how many of them showed improvement? This column showed improvement. So out of the 820, how many showed improvement? So we have 290 that showed improvement out of the 820 that took the drug. So that's equal to 0.354, which is the same as 35.4%. All right, number 4 says the co-ed Cresswell Hall dormitory on the UGA campus houses 220 students. 130 are male, 50 are upper division students, and 40 are upper division male students. A student is selected at random. So real quick, I'm just going to say total we know is 220. And then this circle is blank. So I want to focus on next labeling my circles, okay? And so the two categories I'm going to be looking at are male and upper division. So we know that whenever we're creating a Venn diagram, we want to first focus on the center, okay? This is where they are both types. And so we know that there are 40 students who are upper division and male. So we've got 40 right here. And then we know that 130 of them are male. Well, 40 of those are right here. So that means the rest of them go here. So if we do 130 minus 40, we get 90. And then we know that there are 50 are upper division. Well, if 40 of them are here, that means the other 10 have to go right here. And then we just have to look at what's left on the outside. Well, 90 plus 40 plus 10, 90 plus 40 plus 10, that gives us 140. So the rest have to go on the outside. So if we do 220 minus 140, we should get 80. And so there are 80 students who are neither male nor upper division. So it says the probability of selecting a lower division student given the student is female is, so we need to figure out how many female students are in lower division. So we know that there are 130 male, so that means 90 are female. We just take 130 and subtract it from our total of 220 to get 90 female. So of those 90 female, how many are lower division? Well, if we look at this, we've got male and upper division. So if they're outside of both these circles, then that means they are female and lower division. And so 80 is our total right there. So 80 out of 90 is equal to 0.889 or 88.9%. Number 5 says, a local trade union consists of plumbers and electricians classified according to rank. And so first thing I want to do, just complete my table and find my totals. So 90 and 30 make 120, 20 and 45 make 65. Here we'll have 50. And then if I add up my rows, I'm going to get 140, 95, and 235. And so we've got a member of the union is selected random. Given that the person is selected as an electrician, so we're only going to be focusing on electricians, what is the probability that he is a journeyman? So how many electricians are journeymen? Well, if we look at it, we've got electricians. We have 95 electricians total, and 45 of them are journeymen. So we can say 45 out of 95, and that's going to be equal to 0.474 or about 47.4%. Number 6, it says choose an American adult at random. The probability that you choose a woman is 0.51. Probability that you choose the person you choose has never been married is 0.29. And we need to draw a tree diagram to represent this data. So the first branches, well, you're either going to pick a man or a woman, right? So probability of a woman, it said was 0.51. So that means man is 0.49. Now the probability, the next branches are either going to be they've either never married or they have married. So we've got, let me fix my branch real quick. We've got never married and married. Probability of never married is 0.29, so that means married is 0.71. And that's all we need to do for number 6. The next part says the probability that the person you choose is male who has never been married is therefore about. So male and has been married is going to be this path. So we're doing male and married. Okay? So we're going to have 0.49 and 0.71. So we're going to have 0.49 times 0.71. That's going to equal 0.3479 or 34.79%. Now the next one, John has applied to both Miami and the University of Georgia. He thinks the probability that Miami will admit him is 0.6 and that Georgia will admit him is 0.3 and the probability that both is 0.2. And so we want to make a Venn diagram. And so we're going to have two circles, one for UGA and one for Miami. I'm actually going to change colors here just because Miami is green. Probability that both admit him, so both, let me change, both will admit him is 0.2. So I'm going to start with that in the center. Probability that both is 0.2. Now, probability that Georgia admits him is 0.3. So of that 0.3, 0.2 of it's already right here. So that means the rest, which is 0.1, is right here. And then the probability that Miami admits him is 0.6. So of that 0.6, 0.2 is right here. So that means 0.4 has to be right here. And so if we add it all up, we've got 0.1 plus 0.2 plus 0.4. That's 0.7. And so the remainder has to go on the outside, which is 0.3. And it says, what is the probability that neither university admits John? Well, this value outside the circle represents neither admitting him. So it's just going to be 0.3 or 30%. Probability that he gets into Miami but not Georgia. Well, this circle represents both admitting him. This value represents just Georgia. This is just Miami. This is neither. So the probability that just Miami but not Georgia is 0.4 or 40%. Number 8 says, below is a table that describes the age in years and the gender of students at Penn State University. A single student is to be selected to win an award. And so first thing I want to do is add up my columns and rows. So my columns, we've got 14, 50, 35, 13. And then for my rows, I've got 58, 54, and 112 total. And so it says, what is the probability that the selected student is female? Well, we have 54 females out of 112 total. So it's going to be 54 out of 112, which is 0.482 or 48.2%. And then the last question, what is, on this page at least, what is the conditional probability that the selected student is male given that the student is 25 to 34 years old? So we want to focus on male students who are 25 to 34 years old. So of the 25 to 34-year-olds, we have 35 total, and 16 of them are male. So we've got 16 out of 35, which is 0.457 or 45.7%. All right, number 9, Kim is playing the beanbag toss at the local fair. The game costs $3 to play. Kim has 4 beanbags to toss into a jar in front of her. The prize she wins is determined by the amount of beanbags she is able to toss in the jar from 10 feet away. So if she hits all 4, she wins unlimited ride passes. If she gets 3, she will win a ticket to ride the bumper cars. 2 beanbags made gives her a free bag of cotton candy, and 1 bag she does not win a prize. So it says, what is the probability that Kim wins a free unlimited rides pass or a free bag of cotton candy? So to get the unlimited rides pass, she has to get all 4. So the probability of getting all 4 hits. Remember, we're going to be using the binomial PDF function. Okay? And in this case, we're going to have 4 total tries. When she shoots the bag, you have 2 outcomes. You can either make it or you can miss it. So the probability is just 50-50, right? And then if you want to make all 4 of them. So this is what our function is going to look like. Now let me pull up our calculator here. Okay, so I'm going to go second VARS. I'm going to go down to option A, which is binomial PDF. I'm going to put in 4, 0.5, and 4. If I hit enter, it's going to say that my probability is 0.0625. Now for the probability of, well, she wants to get a bag of cotton candy. So to get a bag of cotton candy, she has to hit 2 bean bags. So to probability of 2 bags is going to be binomial PDF. She's still taking 4 shots, 50 shot on each, and we want to make 2 this time. So I'm going to go second VARS, go down to option A. It's going to be 4, 0.5, and 2. And if I hit enter, probability of that is 0.375.
Yo, I got left my glasses case in here. I don't know.
I'm not sure.
I don't know.
All right, and then, so if we look at this, that's fine. If we look at this, we know that the probability is 0.625 and 0.375. So the probability of getting or, okay, we got to find probability of hitting 4 or 2. So we've got probability of 4 or 2. Since it's or, we're adding, okay? So we've got 0.0625 plus 0.375, which is going to equal 0.4375, or 43.75%. So the probability of her winning a free bag of cotton candy or a limited rides pass is 43.75%. And then the next question, your good friend Pedro, and if you can name this movie, then kudos to you, offers you the opportunity to join his game. The rules are, to play, you must pay him $4. If you pick a spade from a shuffled pack, you win $13. Find your expected value each time you play. So let me just write this down. There are a total of 52 cards, right? Now, of those 52 cards, there are 13 spades and 39 other cards. So 39 of them are not spades, okay? So the probability of picking a spade is 13 out of a 52 total, which is the same thing as if you simplify it, it'd be 1 out of 4. So the expected value you should get is $13 times 1/4, which is the same thing as $3.25. Okay, so you pay $4 and your expected return value is $3.25. So think about that. You might be thinking, oh, that sounds like a good game, but then whenever you do the math, you realize, okay, I'm probably going to lose money on this. So you probably don't want to play with that. All right, and then the last page, we've got Tony only made A's and B's on his last report card. His parents reward him for his grades of A in math, science, social studies, and English according to the following. So if he makes 4 A's, he gets $40. 3 A's is $30. 2 A's is 15, and 1 A is 10. The probability that Tony makes an A is 70%, and the probability that he makes a B is 30%. What is the expected value Tony will earn for his report card? So I'm just going to say 70% is the same thing as 0.7. 30% is 0.3. So all 4 A's, okay? So if he makes an A that's 70% and another A that's 70, and he's just going to have 4 of these. So this is an A, and this is an A, and this is an A, and this is an A. That is the same thing as 0.2401. The payout was $40, and so our probability times payout is 0.2401 times 40, which is equal to $9.60. 3 A's, okay, so we've got 0.7 times 0.7 times 0.7, and then he gets a B then. That means he gets 0.3. That is 0.1029. The payout was $30, and so we've got 0.1029 times 30, which equals $3.09. The next one is just going to be 0.7 times 0.7 times 0.3 times 0.3, which equals 0.0189. The payout was $15, and so we got 0.0189 times 15, which equals 19 cents. And then 1A is 0.7 times 0.3 times 0.3 times 0.3. And so we are going to get a probability of, actually, I just now realized that this part is, this is 0.0189. Going to backtrack just a little bit. Apologize. This, for 2 A's, the probability is 0.0441. So we've got 0.0441 times 15, and that equals 66 cents. The probability of 1A, we said, was 0.0189. The payout is $10. So 0.0189 times 10, that's going to give us 19. It's going to round to 19 cents. And then the probability of no A's is 0.3 times 0.3 times 0.3 times 0.3. That is equal to 0.0081. And he gets $0. So 0.0081 times 0, well, the payout would be $0. So in total, if you add up all values right here, the total payout for his expected value would be $13.54.